So hello. Uh, Let us start. Wait a minute. Another discussion session on analog communication. It's week 8. So let us start the previous year's sample assignments. So the first question is about a strict strain stationary process. So the question is, there is a deterministic process. So deterministic process means there is no randomness in it. So suppose a process is a deterministic process. The question is whether we can say this is strict sense stationary. Option A yes, option B no. So only thing given is this process is deterministic process. Now if a process is deterministic, so we can say its distribution and all the moments are independent of time. So that is a strict sense stationary process. So it is a strict sense stationary process. So a deterministic process, you can think like its probabilities at a particular point, its probability is like a random variable that has a time depend. It is flowing with the time, and it's deterministic. We know what is the function of t. So that is some sort of constant here. So that is what we can say that its distribution and all the moments are independent of time. So it's a strict sense stationary process. Now let us go to the question number 2. Question number 2 says there are two random variables they are y and z. So we have to comment there are four options. First option says that y and z may be dependent or independent. Option B is y and z both are dependent. Option C says y and z both are independent. And none of these. Which of the option will be true? That's the question. Okay. So the question says that the two random variables y and z. Sorry, I think y and z are. I forgot to write that, or I somehow missed it. These are uncorrelated. Okay. Now tell the point. I forgot that. Like y and z are uncorrelated. So if y and z are uncorrelated, whether we can write they are independent or dependent, or it can be both of them are possible. So the thing is, we have said that y and z, these are the two random variables, they are uncorrelated. But this uncorrelated has nothing to do with independent. Just like correlation, does not mean they are independent. So one example, just I am saying, suppose there is a ice cream stall. So the rate of selling of ice creams and the temperature, these two are not, we can say they can be uncorrelated, but they are not independent, because if the temperature rises, the number of selling of ice cream will increase. It depends on the weather. But it may happen even if the temperature increases, particular ice cream shop has not got any buyer. So at that time, we cannot say that they are correlated by weather, but they are not independent. So that is the point here. So uncorrelated does not mean that they are independent. So they may be dependent, they may be independent. Both the option can be true. Number 3. Question number 3 says there is a autocorrelation function a signal xt such that our xx of 0 has the value of 50. This is sort of graphical representation. And this is the value 0. This is the tau domain. And this value is 50. The question is, what is the expected value of 5x squared of t? xt is the random variable, sorry, the message signal, that is the random process, I can say. So basically, the autocorrelation function of this message signal has been given. We have to find what is the expected value of 5x squared t. So expected value of x squared t is xx of 0. We can take out this constant outside, and then this is x square of t. It's clear. So basically 5 into 50 is equal to 250. Now let us go to the question number 4. We have autocorrelation function of this type. So the point is whether this is a valid autocorrelation function. So what we have provided, we have already provided that the autocorrelation function, and that is a rectangular pulse. So the power spectral density PSD, what will it be? It will be a sinc function. So what's the visualization of a sinc function? So these are the negative values here. But power spectral density, according to power spectral density, this is power, contains the power per particular hertz frequency. This quantity cannot be negative. This cannot be negative. So if the autocorrelation function is a direct function, then the power spectral density is a sinc function, and this is not physically reliable. Like, it contains power, and some power cannot be negative in this region, in this region, in this region. So that's the reason this is not a valid PST. I mean autocorrelation function. That, I mean, you cannot say like it is some xt that can give us, like, this autocorrelation function is somehow impossible. Like, the corresponding PSD is negative. That is the only reason. Obviously, given the fact that xt is a WSS process. Okay. I'm just repeating the question number 2 once again as per the request. Question number 2 was like y and z were two uncorrelated random variables. You have to comment whether they can be independent or dependent. Which of the following is true? Or both can be true. So my answer was y was a random variable and z is another random variable. Both of them can depend on another particular condition, but that does not necessarily make them both dependent or independent. Like, they can be uncorrelated, but uncorrelation does not mean they are dependent or independent. They can be independent, they can be dependent. Both of the things are possible in this case. So uncorrelated means they can be independent or dependent. Uncorrelated does not mean that they are independent. Is it clear now? I think it's clear now. Now let us go to the question number 5. this says there is a two level semi binary process can be defined as S of t that can be b or minus b for n minus 1 to t to n t. So basically the time period is for t. This means, and in this time period it can take the value b or minus b. And another thing that has been provided, that b and minus b, both the events can occur with equal probability. And this t and the autocorrelation function we have to calculate. I mean, there are four options. Which of the following is possible? So I'm repeating the question once again. There is a two-level semi-binary process. There is t that can take either value b or minus b. And for the interval, it can take, if it takes the value b, it will keep the voltage b for a time period of t, like this. And both the b and minus b can occur with equal probability. And n belongs to z. That is some fraction like 0.5. So what will be the autocorrelation function within this interval? I mean, this S you can think this way. Okay, let me solve the question. So it is pretty simple because we had given the time intervals t1 and t2, and this is equal to b square if n minus 1 t t1 t2 nt. So it was given 0.5 t and 0.6 t. So basically the value comes b square here, because t1, the first value is, both of them are within this small interval. t1 is equal to 0.5t and t2 is equal to 0.6t, right? So they are inside one small time interval for a particular time period t, because this is 0.1t, 0.6t minus 0.5t, it's a small interval, that is 0.1t. So basically they are inside one small interval, one time interval. And within this one time interval, this will be b multiplied by b. So that become b square here. So the right option is b square. Is it clear? Okay, let's go to the question number 6. Question number 6 is, a random process consists of three sample functions. And I'm writing the sample functions. And each of them occurring with equal probability. So you have to comment whether this process is first order stationary, wide sense stationary, second order stationary, or none. Any answer? what is given is the first sample function is equal to 2. The second one is t comma s2, that is 2t, 3t square. So if we calculate the sample mean of all these three functions, that is 1/3 of y of t comma s1 plus y of t comma s2 plus y of t comma s3. That is equal to 1/3 2 plus 2t plus 3t square. So from this we can say this process is dependent on time. This process is dependent on time. That's why the correct option is none of the above, because of the time dependence. Now let us move to the seventh question. We are giving 4 different power spectrum density. And you have to comment which of them is valid. Not everyone is realizable. The first one is 6 plus 7 omega cube. Second one is 4 e to the power minus 3 mod of tau 1 plus omega square. Option C is 3 plus j omega square. D is 18 del omega. And this tau here is how we calculate the x of t into x of t plus tau, or xx tau. That tau is this tau. So which of them is valid? So first one is 6 by 6 plus 7 omega cube, and this is an odd function. Now PSD is the Fourier transform of autocorrelation. So this is the condition. But autocorrelation this is a real Rxx of tau, it does not have any imaginary part. So if I do Fourier transform of a real signal, it will be a even signal. Its frequency spectrum will be even. So following this PSD, if this autocorrelation is real, then PSD is even. But the first option is PSD is a odd function. So this is not a valid PSD. Now the second one, this itself contains the factor tau, that is Rxx of tau. So in the frequency domain, in the PSD, there should not be any tau value. So this is also not a valid PSD. Because I am repeating once, because this tau is the function Rxx of tau, that become PSD of omega. That sort of thing. So this tau domain converts into the omega. So in the PSD domain there should not be any tau. Just like if you do a Fourier transform of a signal xt, it becomes x of omega. Similarly, Rxx tau become PSD of omega. So this t is now omega. This tau converts into omega. So this is not also a valid PSD. This is not a valid PSD. And obviously, the last option is PSD is always real, but it is imaginary. This is also not a valid PSD. Now we comes to 18 del omega. So 18 del omega will be a function like this with magnitude 18 del omega at omega equal to 0. So this is real, this is even, and contains no term of tau. That's the reason option D is the valid PSD. So the valid PSD is del omega. It's clear for everybody? Now let us go to the question number 8. So question number 8 is, I am going to give you a autocorrelation function of a ergodic process, and you have to say what is the power of that process. So that is Ryy of tau 12 tau plus 4 by 6 plus 3 tau square plus tau to the power 4. So what is the power of the process? So the question we have given, what is Rxx of tau. So what is the power? is ry we have given. So that is ry. What is the autocorrelation value at 0? So this will be 4 by 6. So that is 2 by 3. It was like directly comes from the formula. Like it will be expected value of y square. That is e of yt plus 0, that is expected value of y square t. And for an ergodic process, this is the power of the process. Okay, now let us go to the question number 9. Question number 9 says, consider a random process that is x of t, and this x of t is a sine of 2 omega t plus b cos 2 omega t, and a and b both are random variables. Now if xt is a WSS process, if xt is a WSS process, then what is the relation between A and B? So I am giving you 4 options. First option is expected value of A square is equal to expected value of B square. Second option is expected value of A square plus B square is equal to expected value of B square. Third option is expected value of A square is equal to expected value of A square plus B square. Fourth option is none. Any answer from your side? Okay. Let me solve the question. So xti is given as a sine 2 omega t plus b cos 2 omega t. Now just calculate what is x of 0. So x of 0 is equal to b, because here sine 0 is equal to 0 and cos 0 is equal to 1. Similarly, at x at 1 by pi by 2 omega, it will be equal to a, because sine of what will be the value of 2 omega t here? 2 omega into pi by 2 omega. Sine pi. So similarly this value will be a, following the same conditions. Just a minute. So just take at pi by 4 omega, otherwise it will not come. So here it will be sine pi by 2. So sine pi by 2 equal to 1 and cos pi by 2 will be equal to 0 at pi by 4 omega. So if a process is WSS process, then what is the condition that at let me write it, at t1 should be equal to x square of t1 plus tau. So if now we say t1 equal to 0 and t2 equal to, that is t1 plus tau equal to pi by 4 omega. So this says expected value of x square of 0 is equal to expected value of x square at pi by 4 omega. If the process is WSS process. So we know what will be the value of expected value of x square 0. Expected value of x square of 0 equal to a square, expected value of a square. So expected value of x square of 0 is equal to expected value of a square, and expected value of x square by pi by 4 omega is equal to expected value of b square, following these two conditions. Sorry, this is b square. Just rearrange the terms. This is b square and this is a square, because this is b, this is a. So if I take a expectation over this or expectation over this, these values are random variables, so just taking the square over them and then taking the expectation. So as they are WSS, these two is equivalent. Following this, we can write expected value of b square is equal to expected value of a square. So the correct option is this. Now let us go to the last question of today. Question is, if y of t equal to ax of ct, where a and c both are constant, then which of the following is true? First option is ry of t equal to a square rx of tau by c. Option B is ry of tau square rx c tau. Option C is ry tau is equal to a square rx of tau. Solve this. Let us calculate what is r y y. So r y y is equal to what is the expected value of yt into y of t plus tau. So that is expected value of axct into axct plus tau. That is equal to, there is 2 a square multiplied and a is constant, so I am taking out the a square term. this is x of ct into x of ct plus c tau. So that is a square expected value of x of z plus c tau. If I take z is equal to the variable ct, substitute. So that is equal to a square rx of c tau. So the correct option is option B. So anybody has any doubt about today's discussion session? So there is a announcement that we are going to have one extra discussion session that will be mostly on October 2nd week. So if you have any doubt, any extra, if you have any query, any doubt, you can just mail it to me. I'm giving my mail ID once again. So those questions will be discussed in that discussion session. If you have any extra doubt, so I'll try to discuss all your. I'll try to clear all your doubts.
This can include assignments right from the first one, is it?
Yes, yes, yes.
Okay, thank you. Yeah.
Also writing it in the chat box.
Deep 701, is it?
Yes.
Okay.
So okay, we'll meet in the next Sunday.